morning, everyone. As usual, what questions do you have from the homework? Okay, we'll look at number 19. Okay, 8.2. All right, so we have to find the antiderivative of ln of x over x to the power 10 dx. Okay, so those problems are integration by parts problems. So I'm going to put here the formula for the integration by part. Tells me that the integral of u dv is uv minus the integral of v du. Okay, so just keep it in front of us. All right. So to be able to apply it and apply it correctly, we have to have the form u dv. Okay, so it means we have to rewrite everything so it has this format. So what shall I start with?
Would we start with writing it as ln of x times 1 over x to the 10th power?
Yeah, we have to do that. Because it has to be written under this format. So we cannot really start anything without it. And then it's going to be equal to what? This is x to the minus 10 ln of x dx. Okay, so we have basically, I'm trying to prepare it to write it under this form. So now we have to make our choice for u and v. And as I said, once we make our choice with one of them, the leftover will be the second one. So what was your choice for u and dv?
U equals the natural log of x.
U is natural log of x. And then once she tells me u, I will not ask her dv because dv has to be what's left. So there is nothing left. That should be dv. It has to have this form. So my dv is x to the minus 10 dx. Okay, and now we hope for the best. I mean, we make our choice and we hope for the best. So this give me du is 1 over x dx. And this will give antiderivative of x to the n dx. But that's an easy antiderivative. So it's 1 over minus 10 plus 1, x to the minus 10 plus 1. It means minus 1 over 9, x to the minus 9. And now I go back to my integral and I apply my formula. Equal to u v minus the integral of v du. V is, and the du is that. So it's going to give me equal to minus 1 over 9 x to the minus 9 ln of x minus minus add up 1 over 9. I take it out. And then x to the minus 9 over x, always we have to simplify here. Whenever we have integral of the form x to a power ln, we should have to be able to do some simplification. So this is going to give me together x to the minus 8. Yeah. And then the rest is, we're done. Plus 1 over 8, 1 over minus 8 plus 1, x to the minus 8 plus 1. So that will end up x to the minus 9 ln, minus 8 plus 1, that's a minus 7. So it's give me minus 1 over 72, x to the minus 7. And then at this stage, I add my constant c of integration. Okay. So the integration by part always work whenever we have an integral of the form x to a power times ln. That's really the only way to go, will be integration by part. Okay, now let's look at the rest of them.
So can I ask a question?
Of course, yes.
I don't know if this is right or not. I don't know where you got x to the -8.
Here?
Yeah, like I see the math you did, but wouldn't it be x to the -10?
I do
Because
something
it's,
very stupid.
I don't know, because
Yeah, -9. Oh, that's -10.
okay.
It's me who's goofing.
I didn't know if that was my mistake or not.
No,
So I was kind of.
No. It's me. So this is gonna give me 9. So it's gonna give me 81, right? Thank you very much. Thanks a lot. Okay.
Okay.
It's still 8 o'clock in the morning. 8:06.
Yeah.
I didn't even have
okay.
my coffee yet. All right.
Huh.
Number 20. So, okay, antiderivative of sine inverse of x dx. Okay, so this one is similar to the antiderivative of ln of x, the one we did yesterday. So how can we find a function when we differentiate, we get sine inverse? Looks real hard at first. And the idea we have to use integration by part. There is no other way for those type of problem. So we're gonna make a u. We're gonna make our choice of gb. Okay. And what's the only choice we can make for u? Okay, I think I should start asking you guys.
Just would it be x?
Inverse sine.
What?
The inverse sine.
Yeah. Do we have any other choice? Actually, if I put dv to be the sine inverse, then v will be going back to the same problem. So the only choice we have is the sine inverse. I put this to be my u. My dv is what's left, and like what one of your classmates said yesterday, is basically the 1 dx, or simply the dx. And now we go from there. The du, it means the derivative of sine inverse. Now this is, we tend to forget it, but this is 1 over 1 minus x squared, 1 over the square root. And this will give me v equal antiderivative of dx. It means x. And now we apply it. So this is going to be equal to uv minus the integral of v du. V is x, du is that. Okay. So it's basically x sine inverse of x minus the integral of x over the square root of 1 minus x squared. All right. Now we transform the integral into another one, basically. But is this one, it's not immediate, but is this one easy to evaluate?
Yeah, you use substitution.
Yes, now we have to use substitution. So it's not immediate, but still we ended up with a problem that's easy to do. So usually when I usually isolate the integral. So I'm going to isolate this integral by itself. I totally isolate it. I evaluate it, and then I go back to the original one. So the only way I can do that, I have to set u to b. So I'm going to call it t, just because I don't want to use u again. You can if you want. I don't really care. Then the dt is the minus 2x dx. That's going to give me equal to the denominator square root of t. X dx, the numerator, is going to be minus a half dt. Okay. Now we've done this type of integral several times. Integral of t to the minus a half dt. So this will give me minus a half, 1 over minus a half plus 1, which is a 2. T to the power minus a half plus 1. So this gives me minus the square root of t, or minus the square root of 1 minus x squared. So a lot of those problems that you will see, sometimes we have to do a little bit more work when we end up with the last integral, but it's easy, it's doable. And now I plug in, combine the whole thing together. So we're gonna end up with x sine inverse of x minus plus the square root plus a constancy. So I always isolate what I don't know.
I have a question.
Yes.
At the beginning, what if you take u to be 1? Is that possible, or you can't do that?
It is. Everything is possible. The only question is that does it get us anywhere? Okay, so if I do what you want me to do, I put u to be 1. Okay, and the dv is the sine inverse of x dx, right?
Mm-hmm.
So it's going to be the v. That's the derivative. V is going to be the antiderivative.
Okay, and then we're left back at the same thing.
Exactly.
Okay.
Exactly. You can make, because a lot of time you don't know which choice to make. So if I made this choice, I'm back to the original problem. Okay, and then I don't know what V is. Period.
Yep, okay.
Any other question before we look at the last one? All right, so we look at 59. Let's see what this is about. Okay, 59. They've given us 2 problems and they want us to do it in 2 different ways and make sure that we get the same answer. So we have the integral of x over, I know what's my favorite way in this problem. And they want to do it A by parts and B by substitution. Okay. So first we're going to do it by parts. So we have the integral of x over the square root of x plus 1 dx. Okay, so if we want to do it by part, what are going to be the part? Anybody tried it?
Would u be x plus 1?
No, by parts you cannot take u to be x plus 1. Why?
Is it because of the square root?
Yeah, you can't. It has to have the form. Remember, it has to, forget, I will do that later, u dv. To do by part, you have to have a u times dv. So if I put my u to be this, how are you going to get the u dv in the picture? No way. It has to have this form. So anybody else? Or whatever. Anybody? Okay, somebody tells me try u to be x. If I give u to be x, what should be dv immediately?
One over the square root of x plus 1.
The leftover, absolutely correct. The leftover. That's how the picture should be. Once you put u, this has to have the form u dv. So this is basically, we are looking at it as x times 1 over the square root of 1 plus x, or x plus 1. That's what we are really doing. And this is my u. This has to be the dv. That's the format we're always looking for. And now let us compute the du. So the du is equal to dx. And let me compute the v. The v is the antiderivative of that. Okay, and to find the antiderivative, again, we need a little substitution. t to be x plus 1. dt will be the dx. This will become 1 over the square root of t dt. And we did that a minute ago. This is going to give me 2 times the square root of t. It means 2 times the square root of x plus 1. So again, this is, we have to work it out, but it's fairly simple. It's not very hard. And now I apply my formula verbatim. So it's uv, it means x, times v, which is 2 square root of x plus 1, minus v du plus 1 dx. So it's not really bad. So I'm still having to evaluate this. So I'm going to isolate that. Again, I'm going to be x plus 1. This will be square root of t dt. This is going to give me 2/3 t to the power 3/2. It means 2/3 the square root of x plus 1 to the power 3. Okay, so finally I would get 2x square root of x plus 1 minus 4/3 x plus 1 to the power 3/2 plus. Okay. So if we did by parts, that's exactly how we're going to do it. Any questions? Okay, now we're going to do it by substitution. So problems, of course, could be done in several ways. By substitution, and what do they mean by substitution? So it's again, x over the square root of x plus 1. Okay, so substitution is not by parts, even though they use the same name, u and u, and unfortunately, but what do they mean by substitution? What's going to be my u? Anybody?
X plus 1.
U now.
Closed.
Remember, that's a substitution. The u will have to be the x plus 1. Okay, and the du in this case is going to be the dx. And now I'm going to make my substitution, and this is a substitution that we've learned last time. It's a little bit different. The denominator is the square root of u. The du is the dx. But x now is u minus 1. So x is u minus 1. And now we've done this before. So it's u over the square root of u. We're splitting, or you multiply by u to the minus 1/2, either way. So this will give me square root of u from here minus u to the minus 1/2. Now, of course, math doesn't like the square root. So let's give me u to the power 1/2 minus u to the minus 1/2 du. And now I evaluate. The first one will give me 2/3 u to the power 3/2. And the second one, antiderivative of that is 1 over minus 1/2 plus 1. That's going to give me minus 2 u to the 1/2 plus c. So finally, I will end up with 2/3 x plus 1 minus 2 x plus 1 to the power 1/2 plus c. Okay. Which one would you prefer, by parts or substitution in this particular problem?
You get the u minus
Substitution.
1.
Substitution. I prefer substitution. And did we get the same answer, or we didn't get exactly the same? So let's see. So this gives me that. So by parts, what did we get? They look a little bit different. We got 2x square root of x minus 4/3 x plus 1 to the power 3/2. plus c, okay? Unless I did any stupid mistake. How can I make sure that both those are correct? Could you have done using q equals square root of x plus 1? I think you can. You can do it q equals square root of x plus 1. It will work. I think x, the way we've done it is slightly easier, but you can still do it by setting q to be the square root of x plus 1. Yeah, it will work. Okay. Do you think those are the same answers? How can we check that we're getting the same thing? Or how can we check that our answers are both correct? It's my question.
Plug in a number.
Plug in a number.
And see if those answers are the same.
But if I plug in, if they are both correct for one number, does it mean they are correct for every possible number?
Oh,
no.
Exactly.
Do you take the derivative of both and see if they're
That's a very good approach. You take the derivative of that, you take the derivative of this. Both of them has to give you x over the square root of x plus 1. Okay, so you can take the derivative of both, you should get the same answer. If you don't get the same answer, it means we're doing something absolutely wrong. Okay. All right. So today we are going, any other questions about the problems? So today we are going to keep working along the same thing, integration by parts. And we're gonna do two different type integration by parts. And then hopefully we'll have time to discuss when do you use it? I mean, what type of integral fits the integration by part approach? So what we're gonna see is something called repeated integration by part. It's kind of boring, but repeated integration by part. Okay, so what do I mean by repeat integration? I'll set up the problem and I think it will be clear. Suppose I give you to find the antiderivative of x squared cosine 4x dx. Okay. Now, yesterday or in your homework, we did problem of the form x cosine 4x. Okay, so we did that. X cosine 4x. This is something we did yesterday, and you are supposed to do that along the homework. But now the problem is we have x squared cosine 4x. So how we handle this type of problem? And that's where the idea of repeated integration by parts come into the picture. First, no substitution inside, because the inside here is 4x. Its derivative is 4, so it doesn't really get me far. So the way we're going to do it is we're going to do integration by parts, but we have to do it twice. So let's see how it works. So I'm going to put my first integration u to be x squared du is to x dx. And I'm going to put dv to be the cosine of 4x dx. And now I need to find the v. Is the antiderivative of cosine 4x dx. Okay. Now we have to find this antiderivative. I have an inside, so I need a little substitution. And this would give me integral of cosine t, and my dx is 1 over 4 dt. So this gives me 1 over 4 the sine of 4x. Should almost memorize those type of integral, and eventually I will make you memorize them. So now we apply this, and we're gonna get the integral uv, u, v, minus the integral of v du. V is 1 over 4 sine 4x. du is 2x dx. So again, we would do a little bit of algebra and we end up with that. Minus 2 and 4 will leave me with a half. We can pull it out. And I'm left with x times the sine of 4x dx. Okay, so I put the whole problem in front of us. We started with x squared cosine 4x. We did integration by parts. We got another integral. It's not, this integral is, we cannot even find it, but the only advantage this integral have is that the power of x was 2. Now the power of my x is equal to 1. So we're changing the power from 2 to 1. So now, how are we going to solve this problem?
Does this only happen when our beginning integral has a power that's higher than 1?
Exactly.
Or...
Yeah.
Okay.
X squared, x cubed, x4, all of those, we have to apply integration by parts, and we have to apply it more than once. Okay. So now the question is, we have to take this integral. I'm going to totally isolate it, integration by part again. So here we're going to do integration by part again. That's where the idea of repeated integration. Okay. So I isolated, and sorry, this is not the derivative, so I'm going to erase that because it's 1, not derivative. So now we have to do it again. So we isolate this piece. So it's tedious, but easy. Tedious, but easy. X dx. Okay, now let us do that. So again, we're going to put my u. It's the same thing here. The u is going to be dx. The leftover would be the dv. So if u is x, du is dx. And this would give me v to be the antiderivative of sine of 4x. Again, we have to do substitution. And if you guys do the substitution, we're going to get minus 1 over 4 cosine 4x. So that's substitution in order. So finally, I get this integral. So I'm getting this piece that is missing. So the integral of x sine 4x dx. And those integrals, believe me, they come up. So we're not doing them just because, but they will come up with you. So this is going to be equal to uv. uv minus the integral of v du. So we have to clean up this one a little bit. Minus minus is a plus. 1 over 4 antiderivative of cosine 4x. Okay, so finally we have to put things together. But first I have to finalize this one, x cosine 4x. Now, antiderivative of cosine 4x, we've done it. It's 1 over 4 the sine, and I have 1 over 4 here, leave me with 1 over 16 sine of 4x. Okay, so let me make sure we understand that I'm not going faster than I should. This piece right there, we've already evaluated, and this one gave me 1 over 4 sine of 4x. Okay, that's by substitution. And that's where I got 4 times 4, give me 16. Now when I did the little piece, now I'm going to put the whole problem together. So now we do the problem together. Okay, so we go to our original problem, and we have the integral of x squared cosine 4x dx is now equal to. So now I have to get back to what I had originally, it's going to be equal to 1 over 4 x squared sine 4x minus a half, and then I'm going to substitute the value of this integral by what we got. So what we got was minus 1 over 4 x cosine 4x plus 1 over 16 the sine of 4x. And the rest is just put things together.
I have a question.
I'm listening.
How'd you get the x squared? Was that in the original problem? Because
Yes.
I written down that it was just x.
No, the original problem is
Or like the first.
this one, yeah. Are you with me?
Oh, okay, yeah, I made a mistake. All right, so let me fix that.
Okay, are you with me?
Yes. All right.
Please, everybody, I want everybody to make sure you are with me. Then I'll have minus minus plus 1 over 8 x cosine 4x minus 1 over 32 sine 4x plus, and we stop. So it's tedious, as I said, not hard, just tedious. Okay. And sometimes we call this a reduction approach. So let me say there is a word reduction, a reduction formula. Where is the reduction coming from? All right, let me go back here. So as what your classmate asked, if you had x squared, you did this approach, and not only x squared. If let us say I have x cubed, for example. Okay, x cubed. We usually, again, we're going to use the same approach, but when we use it, we're going to have here x squared. And then we use that again to get x. And then we finish the problem. So we're going to do integration by part 3 times for this type of problem. Okay. Now the same, I did x squared in class. We can cosine. This will also apply for x squared sine. This will also apply for x squared e to the power x for x. So these are the type of integral we can use them. So x squared cosine, x squared sine, x squared e to the x. All those, this approach will do, but it will be repeated. Now, another integral, which is again a nasty one, but you should know it, you should see how it is done, is the following, which again, repeated integration. So we have, find the antiderivative of integral of e to the x cosine x dx. All right. Again, we're going to use by parts to do this type of problems. And okay, what I'm going to choose my u to be and what I'm going to choose my v to be, my dv.
Would u be cosine x and dv be e x?
Okay, u to be cosine and dv is ex dx. Okay, we're gonna try this and see what is gonna happen. So, because there is nothing that guides us in this problem, what to choose, so I just pick what your classmate tells me. Derivative of cosine is minus the sine. If dv, it means the derivative is e to the x. Means v is the antiderivative. It means ex. Okay, so let us see the integral. Becomes what? It's uv. uv. So that's u is cosine, v is ex. So it's cosine x times ex, but I prefer to write it ex cosine x. It's just better. Minus the integral of v du. So I will have ex. I will have minus sine x dx. So this will tell me that the integral of ex cosine x dx is ex cosine x minus it's a plus ex sine x dx. Comment. Comment. Did we improve?
I chose wrong, didn't I?
What do you think? Do you think it chose wrong?
Yeah, because would be repeating the same thing over and over again. Because once we take the derivative of sine, go back to cosine.
So if we change our choice, do you think the problem would be better?
Probably.
Probably. Let's change it. I want you to see that changing will not improve the picture. And why changing will not improve the picture. I'm going to do it on this piece of paper. What type of function we're dealing? We're dealing with nasty functions. Suppose I'm going to change it on this, and I want you to see that nothing will change. So suppose I put u to be ex. It's absolutely the same thing. And dv to be the cosine because of the nature of the function. Then the du is ex. The v antiderivative of cosine is the sine. So we're going to have uv, that's not my issue, minus integral of v du. It's going to be ex sine x dx. Will it matter? Are we going to have the same issue? So even if I make different choice, I still have an issue. I'm ending up with the same type of integral. The reason is the kind of function we have. Cosine gives me derivative is sine. It doesn't really improve it. Ex stayed the same. So the type of the function I have make it hard to choose. And it doesn't matter which one you choose, we have difficulties. So what we're going to do, and this is something you see, you learn, and then you can reproduce yourself. What we're going to do is the following. I'm going to apply integration by parts on this one again. Okay, and see what's going to happen. So this is something you are learning because you don't know how to do it, of course. So we're going to apply integration by parts here. Let's do that. So I'm going to isolate and apply. And then I'm going to put the whole problem together and you will see why it's going to work. So I'm going to put ex sine x dx and do integration by part again. Okay. And I'm going to make the same choice. I'm going to put u to be the sine x, not the same choice, but the same type. The du is the cosine x dx. And I'm going to put dv to be ex dx. V is ex. And integral of ex sine x dx would be uv minus the integral of v du. I'm in a vicious circle. I mean, it's definitely, look, I am in a vicious circle. But now this is the trick that works. That's gonna make this, get me out of the loop I am in. I'm definitely in a loop. Regardless what I pick, I end up with the same stuff because the nature of the function. So let's see how we're gonna get out of this loop in this problem. I'm gonna go back here and gonna substitute this integral by what we got. So I would like to keep everything in front of us right there. So we have the following. The integral of ex cosine x dx will be equal to ex cosine x, I want to change, that's the same, plus Instead of the integral of ex sine x, I'm gonna replace this by its value after we did integration by part. So this would give me ex sine x minus the integral of ex cosine x dx. Okay.
Can you repeat that, how you got there?
Yeah, absolutely. Did you follow me in this one? Did you follow how I got the first one?
Yeah.
Okay. So, and then what did I do? I took this piece. I did what to it? I isolated it, right?
Mm-hmm.
And I use integration by part again. Now I'm gonna plug what I got back in here.
Okay, that makes sense.
Yeah, so I put ex cosine equal, ex cosine exactly. And instead of this integral, I substituted but what I've got. So mathematically what I'm doing is correct. And I know it's confusing for you because, you know, she's looping. That's, you know. But now how are we gonna get out of the loop? I want you to look at what we ended up with and see, okay, how are we gonna get out of this?
Can we take u to be the whole thing to ex cosine x and make dv just dx?
We're still having the same issue. We still have the same issue. The nature of the function is problematic. Give it a try. It's not to have. But what we have in front of us should get us out of the loop. Watch
Could
carefully.
we just move over the integral?
What?
Could we move over the integral to the whole
exactly.
left side?
We're gonna move over the integral. Exactly. Watch carefully. This expression and this are exactly the same. Okay, so now we're gonna basically, as your classmate said, take this and move it there. And that's what's gonna get us off the loop. It means I'm gonna add the integral of ex cosine x. So I'm gonna move this here and I will have 2 times this integral. So this is how we get out. That's the only way we can do this problem. Equal ex cosine x plus ex sine x. That's how we get out of the loop. It's not that we can change our choice. Changing our choice got us nowhere. You can try anything possible. We're gonna, if anything come to your mind, we're always gonna have ex cosine x within the integral. So the only way to get out of it is doing this. Okay, and finally I will have the antiderivative. So very weird type of problems, but they work. That's how they work, no way out. Divided by 2, sine x.
I have a question.
Yes.
So, like, do we have to wait till we find a part of the like equation that equals the first integrand, or could we have done it at an earlier stage, or could we have just moved it at an earlier stage?
There is nowhere else. You have to see it. I mean, there is no place I can move it here. That's the beginning. That's my substitution. I cannot move it because they do different integrals. Okay, applying the substitution again, integration by part again to this piece brought back the cosine.
And so then that's when you move it to the other side?
Yes, yeah, because I needed back the same one. So here I have the sine x. I cannot touch it. I cannot move it because I cannot combine them, pure and simple. By applying the integration by part, because the way it's thinking, the sine x went to its antiderivative, or the derivative, depends what we pick. In this case, it went to the derivative, brought cosine back to the picture. And then by combining them, now I have the same. So I couldn't have done this at an earlier stage. I did not have the same integral to work with it.
So the same thing happens regardless of what order we take the u and the dv in, right?
I did repeat your question.
The same thing happens whether we take EX to be.
Oh, yeah. You could have switched. Yes, you could have switched. Nothing will improve. You do the same way. Even if you have done a different choice, even if you have picked u to be the cosine, u to be the e to the x, dv to be the cosine x dx, you will have to do the exact same thing. Those functions are the nature of the function. That's really what's happening in this problem. In the previous one, we were able to, like when we had x squared, whatever I picked, cosine for x dx, a very different type of problem. The integration by part made me reduce the power of x and gave me x sine for x. But here, nothing happened. E to the x is going to remain e to the x when we differentiate it. So we did not really improve, but we were able to get out of the loop by using the trick we've used in this problem. All right?
All right, thank you.
Sure? Okay. Thanks for your question. Now, the last piece we're going to see is we can use integration by part several times. The last piece is integration by part and definite integral. So integration by part and definite integral. Okay, so always we need to work with definite integral. Those are the ones that they gave me the area, those are the ones that gave me volume, they gave me work, so we need to do that. Now, how we work with definite integral and integration by part? Like substitution, we can do it two ways. First, we can find the antiderivative, the way we've been doing it, use integration by part, and then evaluate between A and B. Or we can use the following formula. It's really up to us. So there is the other formula tells me integral from A to B. So if you use the integration by part, is equal to the same thing with VDU. So it's verbatim the same, but you evaluate the first one between A and B, and you evaluate this between A and B. Okay, so that would be the version for that. So you can either use this, so evaluate UV and then evaluate that, or you can find the antiderivative and then evaluate between A and B. So let me take a very simple problem because we don't have a lot of time. So I'm going to take one of the most basic problem. So let's suppose I say evaluate integral from 0 to pi over 2 of, let us say, t sine t dt. Okay, the most typical integration by parts, all right? So we're gonna do it by parts. That's the only way we can do those type of problems. So I'm gonna do this, u equal to t, and the dv is the sine t dt. This will give me the du is the dt, and this will give me the v is antiderivative of sine, which is minus the cosine. Right? So this would be equal to, so if I apply this formula verbatim, uv, uv. You evaluate this between 0 and pi over 2, minus the integral from 0 to pi over 2 of v du. V is minus cosine, the du is the dt, so I will have a minus from this, and then the cosine t dt. Okay, so you evaluate every one between 0 and pi over 2. So finally, this is equal to, evaluate this piece, plus. Now this one, antiderivative of cosine, that's the sine of t, evaluated between 0 and pi over 2. Okay, so this is t. Plus that, okay? And now we just do the evaluation. At the upper limit, I will have minus pi over 2 cosine pi over 2 minus at the lower limit, I will have minus 0. I don't care, it's a 0. And plus this expression, sine pi over 2 minus the sine of 0. And then we do the little bit of math. Cosine pi over 2 is equal to 0. So this will give me a 0 in here, plus sine pi over 2, it's a 1. Sine of 0 is 0, which is going to give me equal to 1. Now, or you could have done it like this, or. So either you do it like that, or you evaluate this integral the regular way. You find the antiderivative by using substitution, and you will get minus t cosine t plus sine t, the regular way. And then when you want to evaluate the definite integral, instead of evaluate this between 0 and pi over 2 by itself, and this between 0 and pi over 2 by itself, you can evaluate the whole thing between 0 and pi over 2. So you can do the whole expression at once. So when you have definite integral, either you find antiderivative as usual, you evaluate the whole thing between 0 and pi over 2, or you can evaluate, so you should be familiar with both, you evaluate uv between a and b by itself, and then this piece by itself. It's exactly the same thing. So you either use this formula or the way we've been doing it all along. All right. Any questions? All right, so this is basically integration by part. That's our first integration technique after substitution. And we will be learning like three more integration techniques, and you will end with that. Tomorrow you have a quiz, as you guys know. Work will be on the quiz. It will be heavily on the quiz. So please review work, review the problem, review what I did in class, and you will have, of course, integration by parts. Any questions? Okay, bye-bye, guys.